in person, right?
Yes.
Okay. Have you sit anywhere?
Yeah. Just make sure that you wipe off your desk with one of those wipes before you sit down. All right. Let's go ahead and get started. First, we need to take roll. Let's see who we got here. Last name. And then Mata. And that's it. All right, so last time we were talking about equations. And we said that there are three types of equations that we'll be dealing with, and those are conditional equations, which are equations that when we solve them, we find that there are one or more answers to what would satisfy that equation. In other words, things that we could plug in for x to make the equation work. Also, we have identities, which when we solve them, we find that anything that we plug in would work. So that it has infinite amounts of solutions. And then the last one is a contradiction where nothing works, so there's no solution. Now today I want to rewind a little bit before we get back into equations and introduce us to something maybe we haven't seen before. That is the concept of an absolute value. Okay, so an absolute value is a new type of number. The vertical lines on each side of this number tell us that we want to use the absolute value of this number. Last name? Thank you. Now, what do I mean by an absolute value? If we think about this number on a number line, 0 being in the middle there, 2 would be, about right here. So what the absolute value is asking us is really, what is the distance of this number from 0? 2, yeah. It is exactly 2 spaces from 0. So the absolute value of 2 is 2. Similarly, we can look at something like the absolute value of negative 2. Same thing. We look at it on the number line. Negative 2 is out here. So how far is it from 0? It's also 2. Okay? So again, an absolute value treats a number as a distance. In other words, it doesn't have a direction or a sign. Because signs are really directions. So a positive number is in the direction above 0. A negative number is in the direction below 0. But an absolute value ignores those directions and just says, I want the actual value of this number. What is the concept behind this number? Well, for both of these, it would be 2. Another way you can think about it is, if I measure from that wall to that wall, can I get something like negative 30 feet? No. Because again, it's a distance. And distances are not negative, nor are they positive technically. Any questions? None? Okay. So then let's go the opposite direction. Let's say we have an absolute value of x, something we don't know yet, equals 2. Well, then what could be the values of that x? Do what? Negative 2 and positive 2. Good. So the reason we say that is because there's two ways that we could possibly get a 2 out of an absolute value. Either that 2 could be positive or it could be negative. So the absolute value of x equals 2, x has to be either positive 2 or negative 2. Excellent. Any questions? None? All right. So of course we can also have these in expressions. Let's say we have something like absolute value of negative 2 xy over negative 3 z. And let's also say that we know the values of x, y, and z. So x is 3, y is 2, and z is 5. So we're just going to need to plug these into this expression where we have x, y, and z. So we have the absolute value of negative 2. And remember, when we plug something in for a variable, we always want to use parentheses to plug it in. So put 3 into those parentheses there, 2 into these parentheses, and then 5 into these. Now we just need to use our order of operations to solve this. Or I should say simplify this. Now remember that the first step in our order of operations is parentheses, right? Well, the absolute value actually acts like parentheses. It's another grouping symbol. So we're going to do what is inside of the absolute value first. Okay? So what is negative 2 times 3 times 2? Negative 12. Good. And it's still in that absolute value. And just because technically we can do it right now, what's negative 3 times 5? Yeah. Good. Thank you. Good. So once we get what is inside of that absolute value done, we can go ahead and take the absolute value, which, like you said, is just 12 over negative 15. Now, here's the real question. Can we simplify that? No? Yeah, we can. Because 12 and 15 can both be divided by what? 3. So our answer is negative what over what? 4 over 5. Good. Excellent. So once again, ooh, that's loud. So once again, absolute values act like grouping symbols. So we're going to treat them like parentheses. Do it as inside of them first, but it has an extra step in that once we get what's inside of it, we take the absolute value of that number. Any questions? All right. Let's try another one. You might see more than one set of absolute values in an expression. Maybe something like this. Okay, so here I've got a set of absolute values here, but then another set inside of it. Like I said, these work like parentheses. Exactly. So we're going to go to the innermost set of absolute values here, or the smaller ones, and do that first. So we have 7 minus 12. What's that give us? Yeah, negative 5. Thank you. All right. Now, before we go any further, I want to ask y'all, what are we doing between negative 2 and negative 5? Adding, subtracting, multiplying, or dividing? You sure? Multiplying. Again, remember, these are like parentheses. So if we have a number directly on the outside of these quote-unquote parentheses, that means we multiply. Okay, so we can go ahead and take this absolute value now. Absolute value of negative 5 is what? 5. But when we rewrite our expression, we need to make sure that we see we're still multiplying negative 2 times 5. Does that make sense? Okay. And there's not much left now, so negative 2 times 5, and then the absolute value. Good. Any questions? All makes sense? All right, well, y'all are flying through this one. All right. So let's go ahead and start looking at these things in equations then. Now remember, what I said at the beginning of class today was that if we have the absolute value of x equals 2, then what are the answers for x? Negative 2 and positive 2. Okay, so what we have done here is not really solve this thing. What we've done is we have isolated x. We've pulled x out of here, and we said that if the absolute value of x is equal to if the absolute value of x is equal to a 2, then the two possible things that we could plug in for x to get this are negative 2 and positive 2. Right? Makes sense? Okay, so then I'm going to change one thing about this. Now we have 5 plus x in the absolute value, but it still equals 2. Can you say that one more time? Not quite. Now remember, what we set up here is that we're taking what is in the absolute value, in this case x, and setting it equal to what it could be, right? So we will do the exact same thing here. We will take whatever is inside the absolute value, not just x, but 5 plus x, and say that it could be two things. If the absolute value of this whole thing is 2, then there are two things that 5 plus x could be. What are they? -2 and +2. It's the same as what we had up here. Whatever's inside of the absolute value. Ignore that it's an x. We could say that the absolute value of, I don't know, triangle equals 2. And we would still say that triangle equals -2 or triangle equals +2. It does not matter what is inside of there. We could have absolute value of, oh, I don't know, football. Equals 2. And it would still be the same. Football would be equal to -2, or football would be equal to +2. Just because I've added an x here, just because I've added a 5 here, does not make any difference. Maybe 5 plus x is just football. Okay? Anything that is inside of here, we're going to do the same thing. We're going to say, all right, this whole thing somehow gets us a 2. Well, what are the ways that we can get a 2 if we have an absolute value? Either -2 or +2. Does that make sense? Okay. So now we can look at these separately and solve them. So 5 plus x equals -2. This is just a normal equation now. What do we do? Subtract 5. So x could be equal to what? -7. This one. Yep, same thing, subtract 5. That cancels, we have x is equal to -3. So, after solving this, we see that x could be equal to -7 or -3. Does this make sense? What questions do we have? None? Okay. Now, this is something that I know in the past has been troublesome for a lot of my students. So if you feel confused, don't feel bad. However, if you feel confused, please let me know that you need more help with this because, again, this is something that has been troublesome for a lot of my students in the past. All right, so is this a conditional equation, identity, or contradiction? Conditional, good. So remember that we said that conditional equations are the ones where we solve them and we get some condition. We could have one condition, or we could have two conditions like this one, or we could have 3, 4, 5, 6, whatever. So this is a conditional equation, good. It's also a good idea to test and make sure that our answers make sense. So let's go ahead and plug each of these in for x. So if I plug in negative 7 for x, 5 minus 7 is what? So negative 7 in for x, 5 plus negative 7 is what? Negative 2. And what's the absolute value of negative 2? Does that make sense? Good. All right, plug in negative 3. 5 minus 3 is 2. Positive 2. So absolute value of positive 2 is 2. So both of these work. Good. All right, let's try another one. Absolute value of 2x plus 3 equals 5. Okay? Again, it does not matter that I have changed what this looks like in here. What are we still going to do? Is what?
Solve it.
Well, what are we going to do to solve it?
So we can 2x plus 3 plus 5, 2x plus 3 equals negative 5.
Perfect. Anything that is inside of here is going to be equal to negative 5 or positive 5. It does not matter what is inside of that absolute value. We're going to set it to negative this and positive this. Excellent. Good. And of course, now we can solve. So what's our first step in solving? Subtract 3. Good. So now we have 2x equals what? Negative 8. Okay. Good. X equals negative 4. Perfect. Other one, same steps. So we just do minus 3 to get 2x equals, whoops, equals over there, equals what? Okay. And then x equals 1. So, in this case, x could be equal to negative 4 or 1. And again, if you want to plug those answers in and see if they work, you can go ahead and do that. But I already know that they do. Any questions? Okay, then I have another one for you. What's the answer? You should be able to give it to me immediately. Nope. I'll give you a hint. Doesn't matter what's over here. What is the problem with this, though? Oh, the exponents don't matter. Doesn't matter what's inside those absolute values. I could put anything in there. There's a problem with this one. I have an absolute value, right? What do absolute values spit out? Always. Positive. Is it possible for me to have an absolute value that gives me a negative 2?
No.
No. So the answer here is undefined. Oh my gosh. Undefined. So, if you see an absolute value that is equal to a negative number, you should immediately say, nope, can't do that, undefined. There are no answers that will work for this. So what would we call this equation? One of the three: conditional, identity, or contradiction. Contradiction, yeah. There's nothing that we can plug in for x that will make this work. Okay. One more. What is the answer? 0. Because of course, there's no such thing as positive 0 and there's no such thing as negative 0, right? So we only have 0. Excellent. Any questions? None? Makes sense? Okay, so I think we're going to stop there for today. Before you go, Friday we will have a quiz. So that quiz will go over expressions. It's going to go over equations. It's going to have absolute values in it. And it will have some questions about real numbers. Or I'm sorry, not just real numbers, but the number system in general. Okay, so know your real numbers, know your rational, irrational, natural numbers, things like that. Okay? Also, because it is just going to be the quiz that day, I'm just going to email it out. Attendance in person is not going to be a thing. You just need to do that quiz and send it back to me. Okay? So, I will probably not see you Friday, but I hope you have a good one. See you later.